All right, we're recording. On the quiz?
Yeah.
We could have done that before we started recording. I said, did you have any questions? I don't want to record that for the video.
Oh, well, we already did the quiz though.
Yeah, I know, but I might reuse this video, and I don't want the future people.
Question like that, then?
Yeah, we can. But let me say this. So we got it on video. Quiz is tomorrow, October 10th. That's my dad's birthday. Passed away in February. He would have been 79. Anyway, so Wednesday, Thursday, or Friday, check the testing center. They close early on Friday. Don't get there an hour before close unless you only want an hour, and don't get there late, okay? Got 3 days to take it. So I will give you a formula sheet, and I just remembered I haven't sent that to the testing center. I need to do that before I go, or they won't give you a formula sheet. But anyway.
Is it free all 3 days?
No, it's free tomorrow. It costs you $4 on Thursday or Friday, okay? So that was a good question. So here's the one thing that I would like to do. Normally I would say I would open it up for questions to you, but let me ask you a question. How many of you actually did the correlation? Oh, before we do that, I just remembered that. How many, well, I will finish that question. How many of you did the correlation scatterplot worksheet?
I tried to.
1, 2, that's what I thought. That's gonna be like, those are perfect test questions, like perfect. And if you didn't do them, how are you gonna do on the test? Bad, okay? So we can review those. But before we do, since we're talking about confidence intervals, I want to show you a real life example here. I'm going to share my screen from 2016, okay? So this, oh, you know what? This isn't the right spreadsheet, but I'll find the right one in a minute here, okay? So this was the spreadsheet before, oh, sorry, you can't see. People on the video can see though. This was the spreadsheet of the day before Hillary Clinton and Donald Trump were going to win. This comes from the website 538.com. Well, actually, some of it does, some of it doesn't. This is 3 different ones. So CNN predicted every state, and they said, I think this comes from MSNBC. Oh, no. Oh, I see what it did. Okay, so yeah, this first column is from CNN, yes. The first column predicted that Hillary Clinton would get 268 electoral votes. You need 270 to win, so she was 2 shy. And that Donald Trump was 204, and that 66 were undecided, okay, because they were just too close to call. Then we have the 538 projection. They're the coolest website, the coolest statistics podcast out there. They predicted that Hillary Clinton would win 299.2. Obviously, she couldn't win the 0.2. Donald Trump would win 238, and Evan McMullin would win 0.7. Do you guys remember Evan McMullin? Okay. He could have either won 0 or 6, but he would not have won 0.7. So this was a mathematical model. Then you had Hillary Clinton under NBC News. It was 274 to 170 with 94 undecideds. And so you can see here, I thought I pulled up the right spreadsheet, but I think I might have another one here. Hopefully I do. Okay.
So how do the votes work then if everybody votes, but it's only deciding on electoral votes?
Yeah, it's kind of stupid.
So like, why does everybody vote if it matters?
Well, it kind of matters. Here's the problem, okay? Well, we'll go back to that state. So it's based on population, and so every state can award their electoral votes any way they want, okay? Most states, it's a winner-take-all. So even though I believe, let me see here. Well, this was the biggest upset since do you guys remember President Dewey beat Harry Truman? Yeah, it didn't happen. But that was the Chicago Tribune that said Dewey defeats Truman because they printed the paper too soon and Truman won that election. Okay, so anyway, biggest upset since 1948. That was the November 3rd, 1948, with Harry Truman showing that the Chicago Tribune false headline there. 538 did another thing. They said that Hillary had a 71% chance of winning, Donald Trump had a 28.6% chance of winning. That was the same year that the Chicago Cubs were down 3-1 in the World Series against, was it Cleveland? I think it was Cleveland, wasn't it?
Yeah.
And Cleveland had a 70% chance of winning, and the Chicago Cubs won the next 3 games and won it. Okay? So this just goes to show you, just because Hillary, 7 out of 10 times she would have won, but and Donald would have won just 3 out of 10, it still can happen, and it did happen. Utah, this is what I wanted to talk about. Oh. So they talked about Utah's. So they said Trump had an 83% chance of winning. I was thinking I had the results here. Let me see if I can find the results.
Like per state, they take the votes that, so like if the majority of Utah was Republican, then would Utah's electoral votes be Republican?
Yeah, so in this case, and that's what I was trying to decide if I had it here. So I think Trump only got 45% of the vote in Utah, but that was the highest. And so even though he didn't even win a majority because it was split between Hillary and Evan McMullen,
It was still the highest.
he was still the highest, and so he won. It was winner take all.
Okay.
Now, I will just mention here really quickly, you'll notice here, Nebraska and Maine, they split their votes up. So it's not winner take all. Those are the only 2 states that do that. And they do it based on congressional districts or something, which kind of messes up everything. But anyway, those are the 2 states. But most states do winner take all. So even though Donald Trump didn't win a majority of votes in Utah, he got all of Utah's votes because he got the most votes. Okay. I'm trying to find this other file here.
Where some states have more electoral votes than others.
Population.
But it's based on population. Yeah. So the idea here is, and I know I've got a better one than this one. I'm just trying to find. Is this it? Oh, this is the better one. Okay. This is the one I really need to use. Okay. So the fact of the matter is, if we were to look at these here, okay, think of all 50 states as a simple random sample. Okay. Now, according to, here I'm going to turn on this light because it's a little bit hard to see. According to this, you can see what the CNN prediction was, and 538. Okay, 538 was only wrong on 4 states. Okay, so if you count all 50 states plus the District of Columbia, if we count that as a separate state, that would be 51 states. Okay, 47 of the states were correct. Okay. If you assume a 95% confidence interval, you would assume that 95% of the states were correct, right? Well, it worked out in real life. 47 out of 51 states were correct, so 92% of the polls were correct. Okay? Now, the issue comes up because the Electoral College is winner take all, and so you can see nobody talks about the 47 states that they all got right. So, for example, Utah has 6. Texas has 38 Electoral College votes, okay? Was there some other big ones? But the big ones here are Florida, they're up here in red. Florida, Michigan, North Carolina, and Pennsylvania, okay? 2 of those, Michigan and Pennsylvania, CNN had leaning to Clinton, but Trump won those. Now, as we look closer at these, the forecast for Michigan was that Clinton had 48% of the vote, Trump had 44% of the vote. It turns out that Clinton went from 48 to 47%. So she was only off by 1%, okay? And Trump went from 44 to 47, but you can see here that pushed him ahead. And so these 16 votes that went to Clinton actually went to Trump. So that's a 32-point swing because Donald Trump won by 0.3% of the vote. That changed 32 Electoral College votes, that one state, okay? And so because the states are not equally weighted, Florida, Michigan, North Carolina, and Pennsylvania, those are the only 4 states that were wrong. And you can see they weren't wrong by much, okay? Went from 48 to 47, so you'd call that perfect for Clinton. 44 to 47, well, that's a 3-point swing. If you assume it's a 5-point margin of error, that was within the margin of error. However, because it's winner take all, and because they picked Clinton instead of Trump, it's a 32-point swing in the electoral college votes. Okay? So you can also see Florida, 48 to 47, that was off by 0.4%, within a 0.5% on Clinton. But it was off by 2% on Trump, but it pushed Trump to be the winner in Florida. So that's 58 electoral votes that got flipped around. Same with North Carolina, 48 to 46, but 47 to 50, 48 to 47, 45 to 48. So in all four of those states, it swung from initially 268 to 204, and it ends up being that Trump won 276 to 218. Okay? If the states were equally weighted, it wouldn't have mattered. But because those four states are big electoral college states, it swung that. I mean, these numbers are almost reversed. It went from 268 to 276. They're almost reversed. Okay? So, but once again, the 95% confidence interval, they were right about 92% of the time. That's about what we would expect. Real life example. And in fact, all three of these were within the margin of error. Okay? Now they've got the winner wrong, but all of those polls were what we would call good polls because while they did get the winner wrong, which is what most people notice, the math, they were right on the money. They were within 5% margin of error. Keaton, you had a question.
Yeah, I was just wondering why they're so close with Clinton and so far off Trump with the points.
Well, that's what I just explained.
Yeah.
Okay? Because you can see here, in all cases, these were really close votes. I mean, the biggest one, this one was, so this one showed a 0.6%. This one was 4%. This one was 1%. This one was 4%. So if you're assuming a 5% margin of error, all of those were within the margin of error. But because the states are not weighted equally because of this stupid electoral college thing.
Well, do you think they should split the vote, the electrical?
That's what. So the Democrats want to say popular vote wins rather than electoral college, because the problem is you have. So Hillary Clinton easily won the popular vote. In fact, let's talk about that in a second. Okay.
Is that just like all the people that vote?
Yeah, Hillary Clinton won by like 2 million votes, I believe is what it was. Oh, here it is. Oh, actually, I guess when I printed this, it wasn't. I think her margin was bigger. So she got 59,215,000 votes. He had 59,062. So she, according to this, she won by 200,000. But there were a lot of votes. I did this the day of, and they didn't have all the totals. You can still see there's a lot of gray in here, and so those states weren't counted, and those states went to Hillary. But yeah, so she definitely won the popular vote. So from a popular vote standpoint, these polls were right on the money. They correctly predicted. Now, Utah was kind of interesting because you can see here, election day, according to this, Trump only won 37% of the vote. Did McMullen really finish in second place? I don't remember that. Yeah, I guess it would make sense. So McMullen beat Clinton by 1% there. And then Johnson, what was his name from New Mexico? Gary Johnson. Yeah, he didn't do so well. So that's kind of how it went. So even though Trump, chance of winning, I don't know if those results are accurate or if that's a poll. That seems like that's a poll. But yeah, Trump, according to this poll, only 30. I think he did outperform. I think he was in the 40s. I'm pretty sure he was in the 40s. So this is the poll they had. Utah results, only 2 of the counties went to Clinton, but they were both in the majority. Oh, this is the results. Yeah, Trump got 45%, Clinton got 28, McMullen only got 21. So she did finish second in Utah. But a majority of Utahns did not vote for Donald Trump, but he got all of our votes. Okay, so that's your electoral college politics at work. Idaho, I looked at that one too. Yeah, Trump won majority in Idaho. So, and only 2 counties, or maybe that's 1 county. Or is that congressional district? No, it says county results, yeah. So she only won one county in Idaho. So anyway, there you have it. So real life example. So this does go to show you, actually this one's a little bit better. This does go to show you that, 92% of the time they were right. That's about what you would expect. You'd expect on a 95% confidence interval, you'd expect about 95% of the states to be correct. And they were right 92% of the time.
Can we do it like problem 3, something?
Okay, we'll do that after I turn off the video. Now, here's what I want to do. So because you guys didn't do the, because this is going to be a much bigger part of the test, let's do some of the homework. There it is, I think.
Do we have a review sheet, or is it just, yeah, he sent it out right before class.
Oh, okay. I didn't see
Yeah, so here's the review sheet. Let me show you that really quick. If we go to here, oh, by the way, I did post homework 16 since I forgot to have it due today. It'll be due Thursday. So you got 2 extra days to do the homework. You're lucky.
Will the written part of it be in this classroom Thursday? But like this class?
The written test will be here on Thursday. The computer part will be in the testing center, in this class. Yeah, we'll, unless there's a reason to meet in the library, we'll probably meet here from now on. So if you go down here at the bottom, we've got test reviews and review 2. Okay. So it's chapters 4, 5, 12, 15, and 16. Okay. And it has been a while since we created a scatter plot and calculated the correlation coefficient. What are the range of numbers for correlation coefficient? You should know that.
Isn't it like 1?
Can't be greater than 1 or less than. It can be less than 0.
Less than?
Can't be less than -1. So it goes from -1 to +1. 0 correlation would indicate
It's
not correlated if it's, well, if we're looking at linear, we'd have to look at our scatter plot, right? Okay. Now, here's what I'd like to do. How do you calculate the correlation coefficient manually? If only 2 of you did the homework, the extra homework that I posted, you're going to fail this test. Okay? Can I be any more explicit than that? Okay.
Why was it just extra homework?
Which part are we gonna fail?
You're going to fail the computer portion. Okay?
So study that.
So
homework.
definitely study that. So here's what I'd like to do. If I open it up,
Will any of the last 2 chapters be on the computer part?
the last 2 chapters will be on there, but I figure hopefully you just had a quiz on them today and you should know how to do that.
For the computer part.
For the computer part, yes. Here we go. Oh, I'm in the wrong class.
This is all being recorded right now.
This is all being recorded. You don't need all this. No, okay, homework. So this was the homework for scatter plot correlation. Oh, I even gave you the answers. Here, let me look again. Let me go back here. I think I made it an announcement, didn't I? Maybe that's why nobody saw it, because nobody looks at the announcements. Excel homework. Here's the Excel homework. Okay? And I gave you the answers here.
Yeah, it wasn't an Excel
Oh, and
sheet.
sorry for getting it late. That was my tire.
Not why it's late.
That was why I posted it late. Holy cow, that was the most dangerous thing I've ever done in my life. I-15 in the carpool lane when my tire blew out. I've got it's on the outside, and I've got buses passing me as I'm trying not to stick my butt out into traffic, trying to change my tire. It's awful. Anyway. So you've never seen that picture before?
I saw it.
All right. Anyway, I told my kids, I'm like, stay in the car. Do not get out of the car. I'll be the only dead person. All right. Oh, I thought I had better homework than this, but all right. Given the equation for the regression line, what is the best predicted value for y? That actually should be a super easy question. Plug in x, right? So Jordan, tell me how to do this. We're going to do it right here in class.
So negative 3.5
Negative 3.5
times
times 9.6
minus 2.6.
minus 2.6 equals, what does it equal? Here, I'll copy this into my favorite calculator ever. New blank sheet equals that. Oh, it doesn't like my minus sign. Negative 36.2. Negative 36.2. That's the answer right there.
Easy enough.
How many of you just learned something today?
That's easy.
That was easy. But do you feel dumb that you didn't know that before? Okay, you need to study better. Okay, the data below represent the final exams of 10 randomly selected history students and the number of hours they studied for the exam. Be sure to do this by hand or the computer. Make a scatter plot. So here's what we're going to do. Oh, is that? Hopefully I can copy this over to Excel. This is more of an Excel type question here. We're going to see how well this pastes. Not very well. I had a feeling that was what was going to happen. I'm just going to type it in. Hours, and I'm going to put it in columns because it's easier to type on Excel. Scores. And here's what we're going to do. We're going to put these side by side so I can see them. Three, 5, 2, 8, 2, 4, 4, 5, 6, 3. 65, 80, 60, 88, 66, 78, 85, 90, 90, 71. Is there any more data to the right? Oh, that's it. Got it all. Okay, so there you go. How would I make a scatter plot?
Highlight it.
Highlight your data. Insert.
And hit scatter plot.
Scatter plot. Pick the first one. Am I done? No. Add titles. How do I do that? Hit the plus sign. Access titles. What goes down here? Hours studying, right? Hours studied. Exam scores. And what is this? History exam, right? Okay. Does it seem strong, moderate, weak, or no correlation? Probably strong correlation. Is it positive or negative? Positive. Does it seem linear? Yes, linear. Find the correlation coefficient by hand. Okay, so I am going to give you the formula. Can you tell me what the formula is by looking in your notes? I'll have a formula sheet for you. R equals, here I'm going to write it up here.
Oh, yeah, equals.
R equals
1 divided by n minus 1.
1 divided by n minus 1.
And then I don't know what that thing is called. The sum of
Sigma, the sum of
xi minus x bar over 5x.
xi minus x bar over what?
5x.
No, that's not a 5.
Is that an s?
That's an S.
I can't, I'm sorry.
Times
y.
yi minus y bar over S sub y. Ah,
That makes sense.
that makes much more sense. I'll underline both of those. And then we'll close our parenthesis on the sum, right? Okay. So we probably should figure out what my n is. What's my n? Is it 10 or 20?
Oh, that's kind
It's 10. It's a number of pairs. Okay.
of trick us.
I was just making sure. Okay. Since you didn't do your homework, and you told me you did probably.
I tried to do
Okay. This is going to be a big part of the computer exam. Okay. Then what? So I need to figure out the x bar and the y bar, right? X bar, or the means. Maybe I'll just write it that way. How do I find my x bar? Nope, don't highlight the data.
average.
Average. Curse Bill Gates when you do that. Now, you don't have to leave a gap, but I would recommend that you left a space between there because you guys are going to get mixed up and you're going to think that's data and you're going to mess yourselves up. Okay? So always put a gap there. So the mean hours studied was 4.2. The mean test score was 77.3. What else do I need to know? Standard deviations. How do I find that?
Is that, okay.
Nope.
Where's standard deviation then?
It's S sub x and S sub y.
Okay.
Okay? How do I find the standard deviation? Standard deviation, which one? Sample. I'm going to do the standard deviation of the x. So 1.8 days is your standard deviation, or 1.8 hours, and 11 points on your test. Okay? Now what? You guys are supposed to have this memorized. Plug it into what? Find the z-score for the hours. The z-score for the scores. Okay? So how do I do the z-score for the hours? Nope.
This is where I got lost.
That's where you got lost?
A norm estimate.
Nope.
No,
Is
so
it standard deviation divided by the?
I just gave you the formula right here. You should be able to figure it based on this, okay? So far we figured out my x bar. We figured out my y bar. We figured out my s sub x. We figured out my s sub y. Now I need to figure out, this is the z-score right there, right? Okay? So I'm trying to plug it in that formula. So what's x sub I? Equals parenthesis. If you forget your parentheses, you're going to get it wrong. Equals parenthesis. What's x sub I? The first one's going to be 3, right? And what am I going to do with that 3? I'm going to subtract the mean, which is 4.2.
Over the standard deviation.
And then I'm going to close my parenthesis, and I'm going to divide it by my standard deviation.
Absolute.
Oh, now he's telling me the absolute. I was going to do the mistake wrong. Okay. This is technically, this is sort of right, but when I copy it, it's going to be wrong. See why it didn't work? It didn't work because I didn't put my absolute references. I need a SC22. I don't want the standard deviation to change. And C21, I don't want the mean to change. Okay? So the C10, that's the 3 hours there. That's a relative reference. The C21, the mean, is an absolute reference, and the C22 is also an absolute reference, the standard deviation. So 2 of those 3 numbers I want to not change. Only the first number I want to change. Okay? Yeah, the first hours. Okay? So now when I copy this down, it's going to work properly. Okay? Now that you've seen that, we need to do the same thing for the scores. So how are you going to do that, Casey?
You just copy the same formula, but you.
No, you can't copy the same formula.
Okay, so you just do y.
So use your parentheses. Click on what?
5
65 minus
77.3.
77.3.
So I need to make sure so it doesn't.
What's the note? What key do I press? F4. Close your parenthesis. divided by
The standard deviation.
standard deviation, which is 11. Press enter.
F4.
F4, thank you. Okay. Now I'm going to copy that down.
So, why can't we do the norm-estimate one?
We will, but no, I don't think we're even going to need to do that on this. This is you don't need norm as dist on this problem at all.
What does that do? I wrote it does this.
Norm as dist, what does it do?
Distribution. I wrote it with a z-score by hand. I'm assuming.
Yeah, you need to enter the z-score, and what does it tell you?
It tells you the normal standard distribution.
It tells you the area to the
Oh, to the left, or the right.
left or right, which one? Tells you the area to the left of whatever standard deviation you put in there. Okay? Don't need to worry about that on this. Okay?
On the test.
On this problem. Okay? All right, what's the next step? Okay, I'm going to give you this formula here. We found the x bar, we found the y bar, we found the standard deviation x, standard deviation y. We did our z-scores. What are we supposed to do next according to the formula? I'm giving you this formula, but you got to memorize the steps. We need to multiply by 10.
Just each other.
Yeah, we need to multiply the two z-scores together. So this times that. Do I need to F4 these? No, I should not F4 them. Okay. Copy that down. Now what? Now we're going to find the sum. The sum of this column here. We got a sum of 7.61. And we divide by n minus 1, right? So my n was 10, so I'm going to take this number and I'm going to divide by 9. Okay? 0.84. We would call that strong, moderate, weak, or no correlation. Strong correlation.
Is there a way to check it?
Is there a way to check that?
There is. There always is.
How many points do you get if you check it? It's Coral. I don't think anybody heard you on the video.
No, I didn't know if I was right or not, so I wanted to know that.
Yeah, equals Coral. So you can know if you got this one right. Okay? You get no points for this though, right? Okay, so how do you know you're right?
It matches.
It's gonna match.
You should get like a half a point.
What do I highlight here?
You're too.
You're gonna highlight this, comma, this. And hopefully we get 0.846504. Drum roll, please. Smart as a computer.
I
We
hate that
should
we have
get
to learn
something for
this.
checking it.
This is
Then we're
called
showing
math.
We don't know.
What'd you say?
We should get like a point for checking it because we're showing you we don't know.
Okay, now it doesn't ask this. It doesn't ask this, but let's see. So we found the correlation coefficient by hand. You know what I should have asked? I thought I did. I wonder if I asked that on the next one. All of these are the same. Okay, so just for fun, you know what? Let me add another one on here. Find the OLS regression equation. Okay, on the same data set. Okay, I'll be giving you these formulas, but what do you need to know for the OLS regression equation? You need the y-intercept, which we call b, right? And you need to know slope, we call m. Okay? And the OLS regression equation is basically what? Y equals mx plus b. Okay? So we're going to find these two, and then we're going to plug it into this equation. Okay? So how do we find? I think we find the slope first, right? We need to find the slope. What's the equation for the slope? R times f sub y divided by s sub x.
And you're going to give these to us.
I will give those to you.
Nice.
Okay? So how do I find my correlation coefficient? I just did, right? You guys are looking like, I don't know. You're going to ask me a question, I'm just going to say, I don't know, just by default. Okay? All right, so you can click on either one. I'm going to take that one since we did it by hand. Okay? I'm going to multiply that by which standard deviation? The y, which is 11.1. I'm going to divide it by 1.87. So the slope for this regression equation is 5.04. Okay? What is the y-intercept? What's the equation? Y bar minus m times x bar.
Minus or equal?
Oh, it's supposed to be minus.
Oh,
Okay?
now we have M.
So this is, now we have m, right? This is my m right here. M's right there. Okay, so you got to figure m before you can figure out your b. Okay? So what's y bar? 77.3 minus 5.04 times 4.2. Okay? So I've just found my m and my b. So my equation is y equals 5.0443 x plus 56.1139. Is there a way to check that?
Oh, yeah, it's on the
Oh,
chart.
there is. How do you check that?
Add your line of regression.
Add your line of regression. How do I do that? Pick a point. Any point will do.
I think you have to be plus, and then if you right click.
I don't know. I would just right click. Will this work? Oh, kind of. Trend line. Well, that's not that helpful. You can put the trend line on there, but right click and then say add trend line. But when you do that, it pops up this thing rather than when you click that. It doesn't pop this up here. Okay? And you can display the equation on the chart. Go away. I don't want you anymore. You could also display the r squared if you wanted. What does r squared mean? Look at that. By the way, let me close this. That is the same thing that we got there.
If you did that, and
Are you just so amazed that you're so smart? Or that you could have been if you'd have done the homework, you could have been this smart. Okay? All right, what's r squared? Coefficient of variation. And how do we find it? We square the r. And what does it mean?
The percent of variation explained by model.
Variation explained by the model. What is the model? Huh?
What's the equation?
This equation right here.
how come
Okay.
when you square it, it's small?
What'd you say?
How come when you square the 0.846, it's now 7.1?
Because it's a decimal. So
Sorry, which number is I?
if I take 0.2 times 0.2, is that going to be smaller or larger than 0.2?
Now I think it's way smaller.
It's going to be smaller. It's going to be 0.04. It's just, yeah, because of the decimal. Okay?
Will you tell me how you got R?
R squared is just that number raised to the second power. That number is R. Yeah, see R right there.
Correlation, okay.
R equals. By the way, labels are really helpful. If I can figure out what you're trying to do, I'll give you more points than if I have no idea what you're doing. Then I'll be just like, okay? So please label stuff, kind of like I did here, okay? Now, I believe that wasn't a question on here, but let me just look here really quickly because I think I gave you. So here's your, by the way, let me just notice here, I gave you the answers on homework 4. There's problem 1, problem 2, problem 3, 4, 5. I also did the same thing with homework 5, which we haven't looked at. We kind of went over that because I just said, oh, let's use the same one here. Okay. Actually, yeah. To be honest, the homework 5 questions are better than the homework 4 questions. So if you're strapped for time, do 5 because it mostly includes 4. I think except for the first one. Yeah. So, and I have those answers right here as well. Did it download? There it is. Okay. There's 4, there's 3, there's 2, there's 1. And notice 1 is positive, 2 is negative. So there's some good problems here. What do you think of that? Just look at the scatter plot. Does that look like a very good scatter plot? No. Poor correlation, right? So is brain size related to mental capacity? Probably pretty weakly. If it is, it's very weak. Okay?
What's the number to know if it's weak or strong?
What's the number of what?
Like to know if it's a weak or strong correlation? Is just
Yeah, what are the, how do you know if it's weak or strong?
7.3.
Greater than 0.7 is
strong.
strong, absolute value, right? 0.3 to 0.7, moderate. Less than 0.3, weak. 0 would indicate no, and of course it works on the negative end as well. Okay?
Can you go back to that, what we just did?
This one, the one that we just did?
Yeah.
This one here?
Yeah. So where was it then that we knew that it was strong?
Where did we know it was strong? 0.84 says that it's strong correlation.
Oh, okay, so we knew that.
But we kind of eyeballed it and said it looked pretty strong. I mean, if you go back to this other one, where did it go? Oh, it's right here. You can tell that's pretty weak because the dots are pretty far apart, right? Okay. You can tell that one's really weak. 0.04. Well, that's your R squared. It's terrible. Your correlation coefficient. What do we say what that is? Oh, negative 0.2. Yeah, that's weak. That's pretty strong there, and that's pretty strong. Okay. Yes.
Which chapters will be on this test?
4, 5. I think it's on my review here. Which chapters are going to be 4, 5, 12, 15, and 16. Now, I know you guys wanted to do a confidence interval problem. Look at this. I gave you a confidence interval problem. 2 of them, I think. Let's do this one. This is on your chapter review. How many of you are not going to do this? Liars. Okay, so you're all going to promise me you're going to do this. Would you like answers?
Yeah.
Okay, so after you do this, tell me what you got, and the first person who does, I'll give a point of extra credit on their test. And then say, now post the answers and tell me if I'm right. But you have to give me your answers before I'll post them. Okay? All right. Class survey asks incoming freshmen. You know what we ought to do? Because I don't think we did a good one. This is a good one. Rather than do that, I want to pick one out of the book that's a percentage because I think we spent more time on means than we have on percentages or proportions. So I'm going to pick one out of the book at random. This is a good one. Okay, so I'm going to just type it in here. All right, so this is one out of the book. This is problem. I think this is an even one even. How about that? Let's do an even one. 16.4 says a Gallup poll in July 2015 found 26% of 675 coffee drinkers admitted being addicted to coffee.
Wait, are we not? Are we up?
Find a 95% confidence interval. So we got 5 minutes left. How do we do this? Now let me ask you a question. How many of you, and be honest if you can, please, how many of you look at this and have no idea how to do this? 3 honest, 4 honest people, okay?
I don't because.
Is this
there's
going
no
to scare you into studying? Because you should know how to do this. I could have put this on today's quiz and you would have blown it away, okay? All right, so how do you do this? What's the formula that I need?
Population proportion.
The formula for the population proportion. Is it X bar? No, it's P hat. It's going to be P hat plus or minus Z sub alpha over 2 times square root of PQ divided by N. Okay, I will give you that formula, but it's not the X bar formula. Why is it not X bar? Because it's not a mean, it's a proportion, right? How do you know it's a proportion? It has a percent in there. That's not always true, but it's often true. Okay, Kristen?
The difference between the sample versus the proportion.
It's not the difference between a sample and a proportion. This is a sample. It's a mean versus a proportion. Okay, the 25% is what, 25 or 26? Oh, I typed it wrong. It was 26. Yeah, because you saw, so here's the clue. Here is the 26%. That if, and I won't say that's always true, but it's often true. Okay. Now let me ask you another question. In fact, we'll modify this. This is another question, Q2. The average return on mutual funds was 13%. Find a, we'll go 90% confidence interval. If the standard deviation is 7%. That's a big standard deviation, but I don't care. Okay, so these are both percentages. I'm going to give this away. I'm going to give away the answer. This one's going to be a mean. Okay, so this one's going to be X bar plus or minus Z sub alpha over 2, whatever, Z sub alpha over 2 times sigma divided by the square root of N. Okay, now my question to you is, how do you know the difference? Why is this one a mean and the last one was a proportion? Well, it did give you the standard deviation, and I did that because you had to know that in order to do this problem, but that's not the reason. It has to do with mutual funds. Okay, do you guys invest? Okay, do you know that you could lose your money? Okay, so the average return could be negative 13%. Let's pretend that's what it was. Okay, you can't have a negative proportion, but you could have, on a mutual fund, you could lose your money, right? You could lose money. In fact, we'll leave that alone, okay? So it has to do with the nature. Proportion, the percent of coffee drinkers has to be between 0 and 100%, right? Could you get 113% return on your mutual funds? Yes. So it's not a true proportion. Okay? And so because it can go negative or it can go greater than 100%, this is going to be an X bar rather than a P. Okay? Does that make sense? But typically, when you see a percent, it's probably going to be a proportion. But you need to understand, like mutual funds, that would be an exception.
On the test, are you gonna try to check us this?
I'll probably try to trick you.
When you put in a percent, how, I know we're at the time, but how are you gonna plug that first question in?
Okay, let's do the first question
I
here.
don't know.
So your P hat is going to be 0.26. Leave it all as a decimal. We're going to do minus. Your Z sub alpha for 95% is 1.96. I looked that up on the table. I've got it memorized.
Is that all you do? Because
Okay.
alpha's just-
Times the square root of 0.26 times 0.74 divided by n, which is 675. Okay? That's going to be my lower. This one's going to be my upper. This one's going to be exactly the same, except for that minus now becomes a plus. We could say we are 95% confident that between 2156 and 0.3044 Americans are coffee drinkers. Okay, on this one, it's the same sort of a thing. My X bar is going to be negative 0.13 minus my Z sub alpha over 2 for 90%, it's 1.645 times my sigma is 0.07 divided by my square root. Oh, I didn't say what my n was. What do you want n to be? It's going to be the square root of n. 15. There's 15. Pretend there's 15 there. I didn't tell you, so I can't tell you. Okay. I'm going to copy that. I'm going to paste it. I'm going to change that minus to a plus. We are 90% confident that the mean return was between negative 0.1597 and negative 0.1003. Okay? So there's your example of a confidence interval. Okay, don't forget probability. We didn't do any card problems. Hopefully you know how to use a deck of cards. Dice problems. Those will be good things to check. How many of you are going to redo all of your homework between now and Thursday? Okay. If you will redo it, you have a good chance of getting a passing grade. Okay? Please do it. I know I don't collect it, but that doesn't mean you shouldn't do it.
Thank you.
You're welcome. Okay? Do you want me to post this up there?
Yes.
Okay, so this is our review. So subscribe to my YouTube channel so you can see this, but I'll try to add it to my playlist. I can't add it before, but I can.
Where did you get Q in the first one?
Q is 1 minus P.
Okay, that's your number.
You got to remember that. That's like a bunch of times today. All right, so see y'all tomorrow. Please do awesome on my test. You scared me really bad.